Hello, we're going to do a quick recap on what we have learned last week on integration. So we said that integration is the reverse process of differentiation. As such, when you are given an equation of y, so when you differentiate, you will be able to get dy dx, which is also called the gradient function of the equation. So in reverse will be if you are given the gradient function. So when you integrate, okay, this is the symbol or the notation of integration. When you integrate dy dx with respect to x, you will be able to get the equation of y. For instance, if you are required to differentiate kx plus c, where k is a constant, c is also a constant, so what are you going to get is you are going to get k. So as a reverse process, when you integrate the k in the terms of x, you should be able to get kx plus c. There will be a constant after integration. We call c as the arbitrary constant or integrating constant. For example, if you have a question like asking you to integrate 3 with respect to x, so you will be able to get 3x plus c. We have also learned about a basic rule of integration. When you're given an integration of x to the power of n with respect to x, you will be getting x to the power of n plus 1 divided by n plus 1 plus c. For example, if you're given integration of 3x with respect to x, you will be able to get 3x to the power of 1 plus 1. Okay? Then divide by the sum of the power, which is equivalent to 2. Lastly, please don't forget 2 plus c. So hence, your answer will be 3x to the power of 2 over 2 plus c. Some common rules may be useful to you. When you're given an equation like this, where k is the constant, you can also write it as k, factorize the k out from the integration notation and write it as in this form. For example, if it is an equation like 4 over 3x to the power 4 over 3x, okay, you are asked to integrate this. You can actually factorize 4 over 3 and put it outside. Hence, you're going to left with an equation like this. So, 4 over 3, keep it outside the integration notation. Do as usual, x to the power of 1 plus 1 divide by the new power, which is 2. Simplify it with 4 and 2, so you will be able to get your final answer as 2 over 3x to the power of 2 plus c. There is another rule where we find the sum of the separate integrals. So what does that mean by this statement? When you're given fx plus gx dx, it can be broken down into two parts: integration of fx and plus with integration of gx. Example will be when you're given an equation like this: 3x to the power of 2 plus with 4 over x to the power of 2 dx. So break it into two parts. So it is 3x squared tx plus with integration of 4 x to the power of negative 2 dx. Okay, so just do your integration part by part. 3x to the power of 3 divided by 3 plus with 4x to the power of negative 1 divided by negative 1. Continue, simplify 3 and 3, so you'll be able to get x to the power of 3 minus 4 over x, and don't forget your plus c. You don't really need to put plus c all the way along your calculation. Okay, you only need to leave your answer with a plus c at the end.